Hi everyone, let's start numerical analysis. This topic has been my favorite since my college days. Yes, this was one of my electives in third year of my college. Coming back to the videos that I'll be making, I would be referring to my college notes and then Greva numerical methods textbook for some problems and examples, followed by a PVQ videos for that particular topic. Let's come back to the topic. So we know that any equation which is in the form of a0 x power n plus a1 x power n minus 1 plus so on an is equal to 0. So here we see a0, a1, an are all real numbers. So what is this equation called? This equation is algebraic equation. This equation is algebraic equation. So what are the examples of algebraic equations? We can say x cube plus 10x plus 9 is equal to 0, or we can say x power 10 minus 9x power 9 plus 7x plus 1 is equal to 0. So in this algebraic equation, we see that the degree is 3. Similarly, in this algebraic equation, the degree is 10. So this algebraic equation is of degree 3 and this is of degree 10, right? Also, we know how to find the roots of these algebraic equations, correct? If it is a quadratic equation, we find in a different way, and if it is a cubic equation, we are already aware of how do we find the roots. So we also find the roots in graphical way as well, right? If it is a cubic equation, if you see wherever the graph intersects the x-axis is nothing but your roots. So we have different ways. So this is a way we find out the roots for algebraic equations. Now what about equations which are, let's say, like this: e power x plus x square minus 10 equal to 0. What do we call these equations as? These equations are called as transcendental equations. These equations are called as transcendental equations. So transcendental equations, what do we mean by it is the equation which will have exponents or logarithms or trigonometric. So all these kind of equations are called as transcendental equations, or wherever. So these are transcendental functions. If they are present in the equation, we call them as transcendental equations. So how to find the roots of these transcendental equations is something which we are going to see. Okay, so the methods which we will be seeing, right, the bisection methods, all of those, so those help us to find the roots of these transcendental equations. Okay, now we also know that, for example, we have x square minus 1 is equal to 0. We know what is the root of it, right? We know that the root is nothing but x is equal to 1. 1 is the root. So how do you verify that 1 is the root? We just verify by substituting the value of x, right? So x is 1, I am substituting 1 square minus 1 is equal to 0. So this is satisfying this equation. So we know that this is the root of the equation. Okay. Also we are aware that algebraic equations, if they are of degree n, they have n roots, correct? So if it is a cubic equation, we have some cubic equation, the number of roots are 3. If it is of n degree, the number of roots are n. But what about transcendental equations? We cannot tell how many roots are there for transcendental equations. We are going to find out the roots of transcendental equations. We can also find algebraic equations roots also in these methods. Okay. So yeah, let's start with our actual method, which is bisection method. So this bisection method is one of the methods which helps us to find the roots of transcendental equations. So bisection method. So there is an interesting analogy which I read. So how do you find the root of any equation in bisection method is, let's say there is a huge room, and in the room there is a key somewhere. Okay, let's say there is a key here. Okay, you lost your key in the room, or let's say you lost your mobile phone. Okay, mobile phone would be a good example. So now you want to find out where your mobile phone is. Okay, and the room is, let's say, very very big. So what do you do is, you try to ring your phone. Since the room is very big, you'll try to divide the room into two halves, and you'll see if the phone is here or here. Okay, you try to hear the sound and see if the sound is coming from this part or this part. So you might get an idea that okay, somewhat sound is coming from this part, so room might be from this part. So again we divide into half and see, is it from this part or this part, and so on. So similarly is the way for finding out the roots. Okay, we take an interval and we divide the interval, and we check if the root can be from this one or this part. Okay, if we, and then again we try to shrink the interval further. If we feel that it's from this part of the interval, we again shrink the interval and we try to check where the root is. Okay, so let's say our equation is f of x. Okay, now if they have given the interval, sometimes in the questions they give the interval that your root might be in interval 1 comma 2 or whatever. If they have given the interval, it is well and good. Otherwise, always remember f of a times f of b should be less than 0. Okay, so let's see what this is. Okay, now if our equation is, let's say, x cube minus 2x, let's take x cube minus 2x minus 5 equal to 0. Okay, so now let's draw a table. So this is f of x. Here I'll be writing f of x, and here I'll be writing x. What if x value is 0? What do we get? 0 minus 0 minus 5. It is minus 5. What if x value is 1? You get 1 minus 2 minus 5. What is it? 1 minus 7, which is minus 6. Let's say x value is 2. It's nothing but 2 cube 8 minus 4 minus 5. So f of x is minus 1. Let's say now x value is 3. 3 cube 27 minus 6 minus 5, which is 16. Okay, so now we see that if you see f of 2 times f of 3, okay, f of 2 times f of 3 is how much? F of 2 is minus 1 times f of 3 is 16, which is equal to minus 16, which is less than 0. Okay, so when you know that f of a into f of b is less than 0, that means the root lies between them. So the root of the equation will lie between 2 and 3. Okay, that is the first thing which we have to consider. So we have to find out the points a and b such that f of a into f of b will be 0. Okay, so sorry, f of a into f of b will be less than 0. So if you get the root, okay, f of root directly gives you 0, correct? If you know the value of the equation, if you know the value of x, if you know the root value should directly result in 0, okay? But if it is giving as less than 0, that means the root lies between this interval, okay? So now let's start with an example and understand how we can solve the question. So our question is x cube minus 2x minus 5 is equal to 0. So now let's draw a table, and here let's put the value as I. Here let's put the value as xi. Xi is a plus b by 2. Remember, we shrink the function, right? We try to divide the room to find out the mobile phone. Similarly, we will be dividing the entire interval and trying to find out where the root will be. Okay, then let's see what is f of xi. So after we divide, we'll find out what is the value of f of x. Okay, and yes, then we will also see what can be our interval, a comma b. Or let me do one thing, I'll write the interval here itself. So it's xi equal to this. I'll write a comma b. Interval is here. Okay. Now initially, in the first step, what is the interval we have got? 2 and 3. So if you notice here, f of 1 into f of 3 is also less than 0. You can consider this as an interval also. But when we keep shrinking, we again end up getting a value between these two. Okay. So if you find any two values, it is good to take. So we have got 2 and 3. So 2, 3 is A and B. Now what is xi? 2 plus 3 by 2, which is 2.5. Okay. So now let's find out what is f of 2.5. If it is giving 0, we know that it is the root. But let's see, what is f of 2.5? It is 5.625. Okay, we can use our calculator to calculate. It is 5.625, which is greater than 0. Okay, so what is f of 2.5 giving us? It is giving us greater than 0. So what do we want? Now we have 2 and the middle number is 2.5 and we have 3. So the value of 2, f of 2, what does it do? It gives less than 0, right? Minus 1 is less than 0. F of 2 is less than 0. F of 3 is greater than 0. Now again 2.5 is also greater than 0. Okay. So now we'll shrink the interval further and we will be taking these two. Okay. Our next interval will be these two, 2 and 2.5. So second case, it's 2, 2.5. Now what is xi? It's 2 plus 2.5 by 2. So you will get it as 2.25. Now what is f of 2.25? It's 1.891, which is again greater than 0. Okay. So now we have 2, which is giving us less than 0. We had 2.5, which is again giving us greater than 0. And we have middle value as 2.25. It is also giving greater than 0. So instead of finding something between this, we will find out, we'll consider this interval because our root might be between these intervals, right? One should be less than 0, other should be greater than 0. So our third step would be between 2 and 2.25. Okay. So what is xi? 2 plus 2.25 divided by 2 will be 2.125. Now what is f of 2.125? It gives us 0.346, which is still greater than 0. Okay, so we have taken 2, 1 second, we had 2, 2.25, and now the value is 2.125. Okay, so 2 was giving us less than 0, 2.25 was giving us greater than 0, and 2.125 was also giving us greater than 0. So instead of taking this, now again we'll shrink the interval to this. So our next value, fourth value, is 2, 2.125. Okay, now what will be xi? 2 plus 2.125 divided by 2, which will be 2.063. Let's see what is f of 2.063. It is nothing but minus 0.346, which is less than 0. Okay, now we have got a value which is less than 0. Okay, now what we were doing, we have 2 which was giving us less than 0, then we had 2.125 which was giving us greater than 0. Now we have in the middle 2.063. What it is doing, it is also giving less than 0. So what we will take, we will shrink the interval and take one should be less than 0, other one should be greater than 0. So we will not take this part because this part will not be helpful for us anymore. Okay, so now we are shrinking the interval this side. So now the values are 2.063 comma 2.125. So in this question I am rounding to 3 decimals. So actually in the question it was given to round to 3 decimals. So what will be our xi? 2.063 plus 2.125 by 2 will be 2.094. Okay. Now what is f of 2.094? It's minus 0.06, 0.006, which is again less than 0. So what we had 2.063 which was giving us less than 0, then 2.125 which was giving us greater than 0. Now we got the middle one as 2.094. What it was doing, it is also giving less than 0. So now we will shrink the interval further and consider these two. Okay, so a hint to remember is the middle value should be considered always. Along with it, what you have to consider, greater than or less than, is something which you have to understand. If it is less than, if this is giving us less than, we will take something which is giving us greater than 0. If it was giving us greater than, then we would have taken the less than one. This is like a trick which I just remember. So now we have 2.094 and 2.125. Now what would be our interval xi? When we divide both of this, we get 2.110. Okay, now f of 2.110 is 0.174, which is greater than 0. Okay, now have you noticed? Now we got something greater than 0. So we had, what we had 2.094 which was less than 0. Then we had 2.125 which was giving us greater than 0. And now we got 2.110 which is again greater than 0. Okay, so this value we will include. This is greater than 0. And which one is less than 0? This one, correct. Now our interval would be only this. So seventh one, so it's 2.24. It's not 2. It's 0.94. So 2.094 comma 2.110. Now what would be our xi? It's nothing but 2.102. I'm just dividing by 2. I'm adding these two and dividing by 2. So 2.094 plus 2.110 by 2 is 2.102. I'll just erase this. Unfortunately, erasing is taking more time. Okay. So what is f of 2.102 now? It is 0.083. Now greater than 0. So now tell me what would be our interval? 2. So we had this one less than 0, this one greater than 0, right? And we have got something greater than 0. So if you got something greater than 0, you'll include the lesser one, correct? So the next interval is 2.094 comma 2.102. Okay, now xi value is 2.094 plus 2.102 divided by 2 is 2.098. Okay, now f of 2.098 is 0.039, which is greater than 0 again. So by now it would be clear that since this is greater than 0, now we will take something less than 0. So this was less than 0, this was greater than 0. So we will obviously take this 2.094 comma 2.098 is our interval. Are we noticing the interval was 2 comma 3? Now for finding out the root, we have almost shrinked it to 2.094 and 2.098. Now our xi is 2.094 plus 2.098 divided by 2 is 2.096. And f of 2.096 is 0.016, which is greater than 0. Okay, so now this is greater than 0. So this one was giving us less than 0, this one was giving us greater than 0. So what would be our next interval? Right, 2.094 comma 2.096, right? So one is, since this is greater than 0, we will include that one plus less than 0 one. If this was less than 0, we would include this one and something greater than something which gives greater than 0. So now what is xi? Xi is 2.095. Now f of 2.095 is giving us 0.005, which is greater than 0. For 3 decimals, no, if it would have given 0.005, we would have considered this itself as our root. Unfortunately, it is 0.005 still. Okay, which is greater than 0. Again, this was less than 0, this was greater than 0, right? Now we want something less than 0 again. Okay, so 2.094 and 2.095. Okay, since we have got this f value as greater than 0, from the previous interval we will take something less than 0. Now what is xi? 2.094 plus 2.095 divided by 2. So what is the value of it? The value of it is again, I think, approximately 2.095. So when we are getting the same exercise approximately, we can, correcting to 3 decimals, because in this question it was 3 decimals, so we can tell that this itself is our answer. So the root of x cube minus 2x minus 5 is 2.095. Okay, so this is how we solve